More stuff with tangents today. We're looking at this second page in this tangent packet. And we are going to use some of the rules for it. And I just want to point out that you have some of these rules, and then I'm going to actually do some of the problems. I'm probably going to do 3 problems. So you have this whole page front and back to do. So you have 8 problems, but I'm going to do 3 of them. So you're really going to end up just with 5 for homework tonight, okay? Okay, number 1, I just want to point out that right here in your circle book that we did, okay, you have AB plus DC equals AD plus BC. You're going to use that for number 1. That's my only hint. I'm going to let you do number 1 on your own. Okay, so I've got all these things for tangent. I'm just going to review real quick. I've got this rule that if all the tangents quadrilateral goes around it, the opposite sides added together equal each other. Tangents that meet at the same exterior point are congruent. If a radius meets a tangent at 90 degrees, radius and tangents meet at 90 degrees. Tangents only touch a circle at one point. We can have internal common tangents, external common tangents. Internal common tangents can look like this. External, if the circles are inside each other. If they're inside each other but not touching their circumference, there's none. And then we have one more thing, a secant intersects in 2 spots. Okay? So we're going to move to number 2. First, I'm going to read the question. This is a long problem. I'm just letting you know right now. It takes a bit of extra effort. Okay? And we will go through it together. All right. First, we've got ON equals 7. MN equals 24. And N is a right triangle. And we're going to find OQ. No, we're not doing number 1. Number 1 you're going to do all on your own. I'm going to do 2, 3, and 5. Okay? Then you'll do the rest on your own. So number 2, O to N is 7. This length right here is 7. M to N is 24. This length right here is 24. N is a right angle. I want to find Q to O, so I'm going to put an X right there. Okay. So now that I have that, if you're looking at this right triangle, what's the easiest thing for us to find? Is it easy to find X? Would it be easier to find something else that maybe I could use with that later? What do you guys think? If we have 2 sides of a right triangle, what do we usually do? What do we usually use? If I have 2 sides of a right triangle, think about it for a second. What do I usually use when I have 2 sides of a right triangle? Starts with a P. Oh, there we go. Okay, so let's find first M to O. So we're going to say 7 squared plus 24 squared equals MO squared. Okay. And we're going to find 7 squared plus 24 squared is 625 equals MO squared. How do I get MO by itself? What is that thing called to undo a square root? Square root, good. Okay, so MO equals 25. Okay. So now that I have M to O, so this is something we just figured out, this length right here is 25. That still doesn't really help me. I don't know how much to subtract from M to Q to get Q to O yet. So now that we've done all of our basic stuff, let's talk about the stuff we've learned. What do I know about tangents? I know that if 2 tangents meet at an exterior point, they're equal, right? So if we just ignored this part, do you see how MQ and MR both meet an exterior point? So they'd have to be equal, right? So let's mark that. These are equal. Now, if we looked over here at Q to O and O to P, they're both tangents, right? So we agree they're equal. So we're going to mark those. And then down here, really small, PN and NR, they both meet at an exterior point, so they're equal. Okay. So we can use something with that, some equality with that. What is the other thing we know about tangents? So looking at your circle, I know they meet at one point. I don't have any exterior, I don't have more than one circle, so I don't have to worry about exterior or internal angles. What else is true about these? Everybody's looking at our circle? So we know tangents meet at the same point. We don't need to worry about exterior or interior. What else are we going to use? I heard something about a radius. What about a radius? It meets a tangent at? There we go. Okay, so let's draw in a radius. Okay, I'm going to pick the center of my circle. Okay, if I am drawing a radius to this tangent line straight over here, that would be 90 degrees, right? Well, this kind of looks interesting to me. So this length right here and this length right here look awfully similar. How could I say they're equal to each other? So I've got a 90 degree and 90 degree. Can you guys think of any shape that has 90 degrees in it when all other sides are equal? What would that be called? A square. Could I put radius are both the same length, correct? And they meet, this is another tangent line down here. This meets at 90 degrees. Could I say that this is a square and all four of those sides are the same? Yeah. Why not, right? So we're going to make each of these y. It's just another letter. We already used x. Oh my gosh, there is so much. Okay. So now that we have this, let me ask you guys a question. If this whole length is 7, O to N, but I know P to N is y, what would O to P be? That's a number, but I don't know how big y is. So how did you say 5? I don't know. 7 minus y, right? I have 7 and I take away y, and that would give me this length right there. What other length has those two green lines on it? O to P does, and O to Q. Okay, let's look down at the bottom. Okay, this M to N is 24, and R to N is Y. So what would M to R be? This whole length is 24. This part is Y. What is this part right here, M to R? If this was 7 minus Y, there we go, 24 minus Y. And this would be 24 minus Y too, because they have to match. Okay, now I want you to look just right up here. I have M to O, this whole length, is equal to 25, right? Do I have those two parts broken up? I have 24 minus Y is M to Q, and Q to O is 7 minus Y. So could I add those two together to get 25? Okay. 24 minus Y plus 7 minus Y is going to equal 25. Now I just have to do some algebra to find out what Y is, and then plug in Y up here for 7 minus Y, and that would give me X. So 24 plus 7 is 31. Negative Y and negative Y is negative 2Y equals 25. Now let's subtract 31 from both sides. I get negative 2y equals negative 6. Now let's divide both sides by negative 2. Y equals 3. Okay, what is 7 minus 3? Q to O equals 4. Okay, you're going to have to try this, something very similar to this for number 8. I know that was a long process, but you're going to have to try something similar to that for number 8. We're going to do number 3 next. I've got 2 more problems, guys, and then I'll let you work. We're looking at number 3. Okay. So let me talk us through 3. O has a radius of 8. And circle P has a radius of 3. O to P, if I drew a straight line, so let's do that first. O to P, if I drew a straight line, oops, make sure it's straight, is 13. Find the length of this common tangent. Okay. So, what we're going to do is we're going to kind of build rectangles around this in order to find that line. So, do we agree that as long as I touch the middle and the outside of the circle, I can draw a radius anywhere, right? Okay, so right here, I'm going to connect these two and say, there's my radius of 8. Okay? And I'm going to connect these two at the bottom. My line that's drawn to both my centers to show how far apart they are, and my external tangent line, internal tangent line where I want to find the distance. I'm going to mark that 3. Okay. So what I'm going to do is I'm going to build this out and create a rectangle. So I'm going to build this out, and I'm going to add 8 to it. And then I'm going to connect these lines. Okay. And then I want to do the same thing up here, but instead of adding 8 to it, what's this side got that this side doesn't? 3. So I'm going to put a 3 up here. And connect them. Okay. So now let's say, this is drawn a little bit better than what I actually drew, that I've made a rectangles. Okay? Do you see I've got one rectangle that's kind of here? And then I've got another rectangle that's this green one here. Okay? And I've got a third one. I've got this big one, this whole thing. Okay? So, I also want you guys to see that this forms a right triangle. It all comes back to Pythagorean theorem, right? So I've got that right triangle. What's this length right here? It's not 3 and 8, it's 3 plus 8 is 11. It is 90 degrees, though, that's true. This purple length right here is 13, and I'm going to find this length over here, x. Do we agree that this length, and this length are all the same? Yes. It's a rectangle, right? Opposite sides are equal. So, we can do x squared plus 11 squared equals 13 squared. So x squared plus 121 equals 169. I'm going to subtract 121 from both sides. I'm going to get x squared equals 48. And then I'm going to square root both sides, and x is going to equal 6.9. Okay, 4 is going to be almost exactly like we just did for 3. Okay, and we're going to do number 5, because it's slightly different when we're talking about externals. Number 5. The centers of two circles have a radius of 8 and 10 and are 20 centimeters apart. Find the length of this common external angle. Okay? We all see how this slants a little bit, right? Let's build my radiuses where they connect with my tangent line. This side is 8 and this side is 10. Okay? We're going to build a rectangle again. So we know that the distance between these two centers is 20. Okay, this doesn't quite look like a rectangle to me, right? Because this is slanted up a bit. So if I went from right here and went straight over, okay, we could also say this is 20, right? Because now we have this nice rectangle. Right? So what would this distance right here be? If this whole thing is 10, what would this distance right here in blue be? 2, right? Because this distance is 8, so that part would have to be 2. Yep. We know that tangents and radiuses meet at 90 degrees. Do you guys now see this triangle right here? This right triangle? Yeah, it's very thin. So we've got, this is 20, that's the hypotenuse. We're going to look for x, and we've got 2. So we're going to say 2 squared plus x squared equals 20 squared. So we get 4 plus x squared equals 400. I'm going to subtract 4 from each side. I get x squared equals 396. I started going really fast. We okay? I'm going to square root both sides. So x equals 19.9 approximately. Questions? Okay. 6 is just like 5. So I'm going to write next to each of these problems which problem they're like. Okay, so it's easier. 6 is like 5. 7, you're going to use example 3 and 5. You have to do it twice. Okay. 8, you're going to use 2. Let's turn it back over because I skipped some. 4 is just like 3. Okay? And then 1 is completely different, but that should be the easiest one. Okay, you have the rest of the hour to work on your homework and try those.